So this is a Venn diagram set. Uh, some informations are missing, some relationships are given. So read these kind of sets in a way that you tend to take less amount of variables. There's more variables you take, or you're solving equations rather than solving a Venn diagram question. So don't try to take all the regions as separate variables and then make equations on them and solve them after. Then you're translating it to an equation problem. It's not a Venn diagram problem anymore. So let us focus on the information that are given and let's try to identify the important ones. Obviously, the 39 students total is important, and each of whom is enrolled in at least one of the three sports. This information is also important because it tells us that if we draw three circles for these three events or these three sets, in that case, the outside region should be zero. Everybody will lie inside the three regions only. So that is one crucial information. And I mentioned this to our students in our lessons. You guys should be aware of it. You have number of students enrolled only in L is double the number of students enrolled in all three sports. This is the first information, but not only because this is the first information, I will always treat this information as a vital one because it talks about the all three regions. The three region is the most important region when you want to solve it in the less possible manner. So I am going to use some variables whenever a relationship is given, but to that extent only. So I'm going to use certain variables to indicate the relationship, nothing more than that. As in how we are getting the information. So let's start with this one, and let me draw the Venn diagram first. All right. So this is the one we are going to use to solve. So 39 students in total, and the outside is zero. So I always have a habit of drawing this rectangle. If you want, you can skip this rectangle thing for this particular set because outside region is zero. But it's a good habit to keep any which way. Doesn't take too much of time. Now coming to the first information. So it is relating what? It is relating the number of students enrolled in only in L, so this region with the all three regions. So these two are related, and only L is double of the center region. So I'll just indicate this with X and this with 2X. So just an indication. Later on, when I'm solving, this will become crucial for me to understand. Okay, next information is a full circle information. So I can take that up directly. So total of 17 students in G. So this is 17, by the way. So G is 17. The number of students enrolled only in G is one less than the number of students enrolled only in L. So this is also a relationship with this 2x only. So that's a good thing. Let's take that up directly. So this is 2x minus 1, right? One less than only L. Next one says the number of students enrolled only in K is equal to the number of students who are enrolled in both K and L. So this is equal to both K and L is this entire block, right? So X plus whatever. So I'm leaving this information as of now. So I'll just write 4 to remember that 4 is something I'm not taken into account. So leave this information 4 as of now. Fifth one says the maximum student enrollment is in L. So I'm just indicating this by an up arrow. So later on, I'll understand that this is the maximum value. So L is the maximum value that we have. Okay, and sixth one says 10 students enrolled in G are also enrolled in at least one more sport. Now, this is very interesting because if 10 of these 17 students are enrolled in at least one more sport, so implies that this, and this total should be 10, which automatically implies that this region should be equal to 7. Now, as soon as you know that this is 7, 17 minus 10, that is, as soon as you know this is 7, so you get the value of X, right? X is 4. So if X is 4, this is 8. You can put this equal, or you can just scratch out the X that you have taken. So this is what we know, right? Now we can include that fourth information that we had. So the fourth information told me that, let us read that once more. The number of students enrolled only in K, so this part, is equal to the number of students who are enrolled in both K and L. So this part combined. So because I've excuse me, because I've resolved one of the variables already. So now I'm going to use another variable. So I'm going to introduce a y here. And what I know is if this is 4 plus y, this should also be 4 plus y, right? So now I know this particular information. But the interesting part is, if you think about this G circle is 17, right? And the total number of students are 39. Outside is 0. Implies that this plus this 8 must be equal to 39 minus 17, which is 22, right? So 4 plus y plus 8. So that is 12 plus 2y should be equal to 22, or implying y is equal to 5. So again, this variable is also gone. So now what I'm going to do is I'm going to ignore these variables. I'm going to just erase these. For your convenience, if you want to keep this Venn diagram clean, so my recommendation is just draw another one, so that the rest of it we can solve it in a clean manner. So I'm just going to clean this up a bit. Just watch as I'm doing this. So this y is 5. This is known to me. The 4 plus y is 9. So you can draw a separate Venn diagram and plug in these data. And I'm going to take these x's off, because when you're drawing the separate Venn diagram, you don't need to write these x, 2x minus 1 and all. So now this is purely numbers, right? So this is actually good. So let me just clean this part as well. And the fourth information is also taken. So let me clean that also. Okay, great. So now everything is known. So one thing I've not accounted for as of now, the L value has to be the highest. So this L circle should be the highest here, right? Now, how to incorporate this? So let us compare both of the other two circles here. So when I'm comparing L with G, the L total has to be greater than G total, right? So if you think about this, this part, let me just shade this. This part is common between L and G, isn't it? So that is not going to create the comparison point. All we can say is this 5 plus 8 should be greater than this 7 plus whatever is here, right? So 5 plus 8 is 13, should be greater than 7 plus whatever is here. Now, check this out. I mean, we have two regions where we don't know the data, right? So let me indicate this by some A and B as of now. So if I do that, now what is the remaining part? So we know that this is 9, 5, and 8. So that's a total of 22. This is a 4, so that is 26, plus a 7, that is 33, which implies that this A plus B should be equal to 6, right? Now, again, coming back to this comparison, L greater than G. If you remember, this 5 plus 18, 8 should be greater than the 7 plus B, right? So effectively, this B cannot be 6. It cannot be anyhow more than 6, because A plus B is equal to 6. A cannot be negative. So if B is 6, then these two become equal. That is not allowed. So B has to be less than 6. Or in other words, A has to be greater than 0. So that is one thing that we are getting from this particular information, right? L greater than G. But also L has to be greater than K. So we also have L greater than K, right? Now, if L is greater than K, similar to the previous analysis, this region is common between L and K. So that is not a comparison point. This part of L has to be greater than this part of K. So A plus 8 has to be greater than B plus 9, right? So this is interesting, because if A plus 8 is greater than B plus 9, it implies that A has to be greater than B plus 1. So this reduces some of the cases, right? So if you think about this, I mean, A greater than 0 becomes irrelevant now, because it has to be greater than B plus 1 any which way. So I'm just taking this off. So what are the possible cases here? Obviously, A6 and B0 is allowed. B can be 0, no issues there. A5 and B1 is allowed. A4 and B2 is also allowed, but that's it, nothing more. So we cannot have anything else out here, right? So we cannot have 3, 3 or 2, 4. We cannot have those kind of things, because A has to be greater than B plus 1. So that is all we can say about this set. So now let us go into the questions. Okay, question number 9. What is the minimum number of students enrolled in both G and L, but not in K? So both G and L, but not in K is this, right? A. And we are looking for what is the minimum value of A. So we know already the possibilities of A. The minimum value of A has to be 4. So that is the answer for this question. Question number 10 says, if the number of students enrolled in K and L are in the ratio 19 is to 22. So what is the total of K? Let us take those in terms of AB only as of now. So K total is 4 plus 5 is 9. 9 plus 9 is 18. So we have 18 plus B. And L total is 8 plus 5, 13 plus 4. So that is 17. So 17 plus A. Now this has to be in the ratio 19 upon 22. Now check this out. I mean, this can only be possible if A plus B is 6, right? So there are not too many possibilities of A and B that are available. So the only way with where this is possible is when B is equal to 1 and A is equal to 5, right? So then we have 19 and 22. So we are looking at this case. So what is the question? What is the number of students enrolled in L? So in L we have exactly 22 students. So the answer for this is option C. Okay, for question number 11, now when you are taking the test, you'll have one question in front of you, on your screen, right? So when you're reading this question number 11, you'll automatically find that there will be a change in this Venn diagram. So it's a good habit to actually check the next one because there is one question left in this set, right? But if you read the premise of question number 11 and 12, it's the same. So you can go ahead, pause the video and check this. Or if you have taken the test, just you know that. So 11 and 12 have exactly the same premise. So if you have the same premise, the advantage is I can go ahead and change whatever I want to because these are the last two questions any which way, right? So let us do that. So we have, due to academic pressure, students who were enrolled in all three sports were asked to withdraw from one of the three sports. So whoever was in all three sports, so these four individuals were asked to withdraw one of the sports. So if they are withdrawing one of the sport, where do they move to? I mean, which region do they move to? So suppose somebody is withdrawing the G. I don't remember what was the name of the sport, but somebody is withdrawing G, let's say. So that person will move to this region, right? Somebody who is withdrawing K will move to this region because they will still be playing G and L, right? They will not be just playing K. Similarly, if somebody is going out of L, going out of the subscription of L or whatever that was, enrollment of L, they are still playing G and K. So they'll move to this region, right? So that is where the movement will happen. It will happen either to this region or to this region or to this region. So the net movement has to be 4 because after this adjustment, the center region should become 0, right? So let us understand how to handle this. So what I'm going to do is I'm going to draw a fresh Venn diagram. And this time around, I'm not going to draw the rectangle because I know anyhow the outside region is 0. So let me just do this. So G is 17. This is K. This is L. By the way, G is not going to remain as 17. So let me take that off as well. That might actually change depending on the movements. So this is 7. I'm not going to plug in the variables as of now. I'm just going to plug in the values. So we have 5, we have 8. So these are the numbers, right? I'm going to write this as, or let me, just I'm writing this way. I hope you'll be able to understand once I clarify. Because when I'm drawing this Venn diagram, I can see that there is a here, right? So I'm indicating the first part with A. So I'm going to plug in these values as I get to know, and I'm going to do the same thing. So these are some blanks. I'm going to fill it up. So let's do that. And also there will be an increase in this part. So 5 is known, but the other part, whatever is the increase, is not known. So let's try to fill this up. Now check this out. What are the information that is given? So after the withdrawal, the number of students enrolled in G was 6 less than the number of students enrolled in L. So the G total is 6 less than the L total. So G plus 6 should be equal to L. So this is one relationship that is given in terms of the total circle value. But I'll come to that in a while because this is a relationship. There's a lot of missing data as of now. So let's not go into that. Let's take the next one. While the number of students enrolled in K went down by 1. So this is interesting. See, if I move this 4, anything that I move from here to here, that is not going to change this K total, right? It's still in the K circle. Same thing here. I mean, it's still in the K circle. So whatever goes out of this K circle will be the reduction in K, right? So it is going down by 1 implies this is 1. So this is first of all known. This should be becoming 0 after the change, but I'll do that after a while once I make this adjustment. So this is reduced by 1 already, right? So let me strike and write a 3 here. So now there is 3 remaining to be transferred. So there will be some transfer happening here and some transfer happening here. But that was the other data. There is no more data available. So this is the other data that is there, right? So the reason I did this, you'll understand this now. Check the values that are already known. If you remember from the previous, when I was solving this set initially, when I'm comparing G and L, this region is not relevant, right? Because this region is common to both G and L. So that part I don't have to compare. All I have to compare is this much and this much, right? Now check the constants or the numbers that I already have here. So here we have 8 plus 5, that is 13. So 13 is already there. So there will be something more to it. And there's a 7 in G, right? So G part is 7 plus something. So this is the G part and this is the L part. So this is plus 6 equal to this, right? But I hope you can notice that 7 plus 6 is anyhow 13, right? So which implies that whatever blanks we have here and whatever blanks we have here should be equal, isn't it? So what are the blanks that are there? Here we have 2 blanks. One of them is B, but the other one is not known. So there are 2 blanks here. This total of this blank and this one should be equal, right? So broadly speaking, see, this part, let me just increase this. Give me a minute. Yeah, just enlarge this Venn diagram a bit so that it's easy for you to understand. See, this 3 is moving to this part or this part, right? This blank is from B, right? So that was the initial blank which was not known to us anyhow. So what are the possible movements? So we have to balance this out, right? So there are 2 possibilities only if you broadly think about this. So either this is 3 and this is 0, and then this is 3, which is not possible because B cannot be 3, right? The possibilities that we have is 0, 1, 2. That cannot be, I mean, none of the cases are B equal to 3. As I said, I mean, this total should be equal to this one coming out from this idea. So if I put a 3 here, this becomes 0, and this has to be 3, which is not possible, right? You cannot have a 1 here and a 2 here, right? Now, this cannot be negative. So the only other possibility is this becoming 2 and this becoming 1. In which case, this also has to be 1. Now you can see this 2 and 2 balances out, right? So if you can visualize these kind of things, it becomes a little simpler because now you see that B equal to 1 is the possibility that we're picking up. And when B is equal to 1, A is equal to 5. So we are also getting this value. So this is 5. So now we are just down to the final solution. I mean, everything is filled up. So let me quickly just add these up and substitute. So there's a 2 here. 1 plus 1 was there. You have 5 plus 1. So this is 6. This becomes 0, as I was already saying. So this will be becoming 0. And this thing is 7. 5 plus 2. So this is the final Venn diagram, right? So this is G, K, and L. So let me just draw that rectangle as well. So this is 39 and outside region is 0. So this is actually pretty fast. I just wanted to elaborate in a detailed manner. If you observe it in this way, it becomes very fast. Otherwise, you might be taking 4 or 5 cases and then trying to evaluate everything. That is still fine, but then it will take a little bit more time. So anyhow, question number 11, whatever premise was same for 11 and 12. So let's quickly solve the answer, get the answers now. So after the withdrawal, how many students were enrolled in both G and K? So both G and K, please understand it's this entire part, but the center region is anyhow 0, so it doesn't matter. So the total is 2. So this is 2. And after the withdrawal, how many students were enrolled in both G and L? Similar type of question, but G and L this time. So that is 6. So option D is the answer. So I would say this is medium level difficulty because it depends on how you are solving it. If you can solve this smartly with less number of variables, that will obviously save a lot of less amount of time. Do relate the info with variables, but do it with the minimal variables possible. Don't try to take every region as a separate variable. That will overcomplicate the solving part. So I would say somewhere in the range of the last 2 questions were a little lengthy because you have to solve this premise once again. So let me break this down. So I would say initial solving and including the question number 9 and 10 would take somewhere in the range of 5 to 6 minutes, because question number 9 and 10 are pretty straightforward. A little bit of solving is required, but then It's pretty straightforward. And for the last two questions, I would say another 2 to 3 minutes should be required. If you can solve it in below 2 minutes, that is fantastic, actually. So overall time, I would say 7 to 9 minutes for this particular set. That should be an ideal time. So I hope this idea was understood. Venn diagram, remember those key ideas. I've mentioned this in our lessons any which way. But those who are not enrolled with us also try to remember this. So the center region is quite important, and also that try to do it with as less amount of variables as possible. So thank you for joining in.